Hey, my name is Andrew from Aero-Gro, and today I'm just bringing you into the lab, take out these headphones, to do a little work again on a digital controller that's getting constructed for a customer. We're actually going to be working on two of those today, and also I'm going to show you a pretty cool tool for mixing up nutrients, for those of you who have to mix up a lot of nutrients. And I'm going to show you a really cool little trick where if you're putting together your own parts, you can put threaded inserts into your parts and make them super strong and make them more adaptable to the greenhouse environment. So without further ado, I'm just going to get to work here. This is just the DIY lab. So this is my workspace and I'm just bringing you into it, and I'm going to share a few things. Now, what you're looking at here, let me give you the Skycam view, actually. You get a better look at this. What you're looking at here is a magnetic stirrer. And it, whoops, where the heck is this? Hold on. OBS. Okay. How come? Okay. So what the heck's going on here? Ah, there we go. Sorry about that. Yeah, sky view here. This is a magnetic stirrer. I'm going to turn it off so you can see what it looks like when it's off. So basically all this is this is a giant magnet, and this is a giant pitcher. It holds 1 gallon of water. Actually, a little more than that. This is actually measured in metrics, so it's 5,000 milliliters. And that sits right on the top of the platter here. Inside of here, there is a magnet. It's a bar magnet, and it's like a propeller. It's spinning around underneath the surface here. You can't see it, but it's under there. And its job is to spin. Let me show you the, this is just a piece of metal. Yeah, so it sticks to it like that. Yep. And when it turns on, it spins like this. And that contacts a small, grab it out of the water here, a small magnetic pill. It looks like a Tic Tac. It looks like that UFO video they keep showing on TV. It looks like that. It's basically a magnet covered in plastic. And what you do is you take your solution with your nutrients in it, and you put your water in there, your nutrients into the water. You take this little pill-looking doodad, you drop it in there into the middle, sticks to the magnet, and then when you turn it on, it'll start to spin. Watch this. Watch carefully, the little white piece. There you go. It'll spin up. And then after just a little bit, maybe 10 seconds or so, you'll see a whirlpool form on the surface here. Let's see if I can get a better view here. Let's try this. Actually, yeah, let's try the camera view here. Okay, there's your vortex. There's that little whirlwind deal that cranks in the middle. And that's actually stirring everything. As you can see, it's going around the middle. Now, it looks like it's not moving very fast because of the frame rate of the camera that I'm using, but actually it's moving really fast. It's moving at 800 revolutions per minute. But the camera is shooting at 60 frames a second. So, divide that into it, and it tends to slow it down. It's like aiming your camera at a fan, a spinning fan. So there you go. That mixes up the nutrients, and that just goes for several minutes, and then it will automatically turn itself off. So what I do is, let's say, for example, I'm just mixing up some pre-mixed solution that comes with the Tabletop Gardens. This is just the A side of it. So if I throw this in here, all right, then it just, over the period of several minutes, again, that's moving really fast. It just doesn't look like it on camera. That will dissolve all those little pellets. I'm going to go ahead and dump the B component in there as well. The B, I already dumped the A, dumping the B like that. All right. So normally, I mean, if you wanted to make this go faster, you would heat the water up a bit or heat up a small bit of water and then put your nutrient salts in that warm water, mix it up, get it to dissolve, and then add that mixture, which is very concentrated, into your gallon of water, 5 gallons of water, or whatever it is you're doing. That's how you would mix it. You use hot water to dissolve the pellets. This allows you to do it at room temperature, which is kind of nice. And it's just, it's just easier and I guess safer in a way or something, cleaner, I guess. You don't have to dig out all the kitchen tools to do it. You just have this setting over to the side. That's what we do here anyway. So it's a really nice tool. You can get them on Amazon. I'll put a link to the search phrase below so you can find one. They're not very expensive. They start at, I think, around $40 or $50, and they go up from there. Obviously, you can get expensive ones, but you don't have to. So that's what it looks like on the front here. You push and hold to turn it off. Okay. You can adjust your revolutions per minute. You can adjust how many minutes it stays on for. And to turn it on, you push and hold, turns it on, starts to spin. Like that. Spins up to speed, push and hold to turn it off. Now, if you want to change something in the settings, quick push, you can change the amount of minutes it stays on. Quick push again, change the speed, like that. RPM. I like it at about 800 for this amount of water, and that seems to work pretty well. And again, push and hold to turn it on. And that's how you do it. Simple as that. And it runs off of a plug-in adapter, which is 12 volts. A very standard 12 volts, just like this. That's your adapter. And Bob's your uncle, as they say. Super simple, right? And that will save you, I mean, I think in a lot of cases it will save time. It definitely, for me, is more of a convenience thing. Let's see here. Where am I? And, it depends what you do and how you're doing it and how often you have to mix nutrients as well, obviously. So I just wanted to show that to you, and I'm going to get this out of the way. Actually, I'm going to set it to the side and let it keep mixing because it's not dissolved yet. And it'll probably take, a good solid 10 minutes, a single cycle of this, I'm sure, to dissolve that. That's typically what it takes. So there you go. Hope that was helpful. So what I also would like to show you is something called, these are brass inserts. And let me get on camera here. Okay. So as you know, if you watch this channel at all, I do a lot of 3D printing here at Aero-Gro, and all of our equipment is placed into 3D printed cases and hangers and all kinds of different things. And everything is held together, more or less, with thumb screws. I love thumb screws because they allow you to really easily take apart a piece of equipment for cleaning, for repair, for whatever. If you want to put a different size of something on it, like a different size hanger, you can do that. And they just work really, really well. But in order to get 3D printed parts to join together, obviously, you need a little strength. And you get that strength in the form of these little brass inserts. And a whole box of them here. And what you do is you heat them up and then you set them into the plastic, and then forever you'll have a nice stable place to screw in your thumb screws. Now, obviously an opening or a hole would need to be designed into your 3D design. So I realized that a lot of you may have 3D printers, but you don't have the designs ready at the helm. So I'm going to post a design that you can print at home that will hold these meters. Now, it's not going to be all fancy schmancy with sides and all kinds of things like I do with my controllers here, because I don't know what you're doing. I want to give you something more generic. So I'm going to make you a face plate like this, just flat plate with the tabs on the top here. And you can print that. You can print that at home if you have a 3D printer. Also going to make available by demand a kit, which will allow you to assemble some of these things that you see on the show. So stay tuned. But yeah, this is going to be how you do these little inserts here if you want to do these at home. You can get these on AliExpress. They're measured in millimeters. These are M5, meaning a 5 millimeter opening in the end there. That is 5 millimeter opening. So they're called M5. And you can get them by the dozen, by the hundreds, by the thousands, however many you need. And I get lots and lots of them because, like I said, I'm kind of crazy with thumb screws. I love thumb screws. So how you do this is like this. Now, this is a little dangerous because we're using flame. So, you know, I do put that out there. Don't try this at home unless you're ready to try this at home. Okay. So to make this a little safer, I use a smaller torch. And this is just a butane torch, kitchen torch, that is used for making creme brulee or whatever. You fill it up like a normal lighter, turns on like this, and adjust the flame up or down like that. And I usually keep it about maybe 1.5 inches long in flame. I'll show you in a second. And then I have a sacrificial thumb screw that's extra long. And it is an M5, that's 5, right there. M5, it is a 5 millimeter screw. You can see it's taking a little battle action there. It's a little scorched at the end. We've taken fire, Captain. Yeah, like that. So what you do, to start, I want you to notice something. These little doodads, they have, let's see if I can get a pointer here. They have, on one end, it's knurled. I get a grip here. On one end, it's knurled, and on the other end, it's smooth. There's a knurled end and a smooth end. That's really important because what you want to do is you want the knurled part that's really rough and grippy, to be on the top where you're going to be screwing into. You want the smooth side to go into the hole first, right? So what you're going to do is you take your sacrificial M5 screw, you screw it on there. Move this so you can see it. Screw that on there. And what you want to do is you want to screw it on until the screw is just coming through the end there, just peeking through the other side. You don't want it all the way through, because what's going to happen is when you go to heat it up and put it into the plastic, if you have too much thread sticking out, the plastic's just going to goop up the threads, and then it's going to be almost impossible to unscrew this later. So to prevent that, get it flush with the end as best you can, then heat it up, and double check that the smooth side of this insert is facing the end, the side that's going to go in the hole first. The smooth part goes in the hole first, okay? Like that. Now we're going to heat it. Set the torch there. And what I'm going to do is, oops, I need one that actually needs to be done. Let's see here. Oh, yeah. Before I do this, hold on. These are already done. I didn't realize that. I did those on the video the other day. I believe I did that on the video. But what we're going to do instead is I'm going to put some of these threaded inserts into this here. Now, this here is a basket holder, a 2-inch. It holds a, do I have any net baskets? I do not. It holds a 2-inch net basket in the top here. Let me go grab one real quick just so you can see. Whoops. Whoa. Almost died. All right. Get a basket. There we go. And what happens is the basket goes into that. And then ultimately this will go on the top. And then we'll have thumb screws in here. Oops. A thumb screw there. A thumb screw there. And then flip it over. Whoops. What you'll see is this is an adapter that allows you to take a plain food grade white bucket, and we're going to make a plant, like a cannabis plant or a pepper plant or tomato plant, any kind of viney, stalky plant, single plant will go in this bucket. We're just going to make a hole here and put this in it. And then from the other side, thumb screws will allow you to attach it to the bucket. So there'll be 4 thumb screws, 2 on the top to hold the basket and 2 on the bottom to hold it to the bucket lid. All right. So this will get out of the way. And before we put those little inserts in, we want to pre-drill these holes, and I'll tell you why. Because the plastic, again, once you put that insert in there, it melts the plastic, and if too much plastic is in there, it will cause you problems. It will gum up the threads. It'll just be difficult to work with it. So what I do is I pre-drill the holes for the brass inserts. Let's see here. Yeah. Okay. So I want this. And this is well, it's just small. I think it's 4.7. Just smaller than 5 millimeters, so that there's a little bit of plastic to melt around that knurled top of the brass insert. I'll show you. Okay, so we drill this out. Yeah. Check something. Yep, that should be fine. Drill this out. That, ooh, I need a new drill bit. That sucker's getting dull. Wow. Okay. Wow, really dull. Okay. And actually, this is a sacrificial part, one of my original designs. The final design, I probably won't have to drill that much. I'll simply make the hole a little bit bigger, so I have to drill a little bit less later on. But this was a test piece. So here we go. Okay, that's already on there. Now you can see that when I put this smooth side in there, it's closer to fitting on its own. It still won't fit. So there's a little bit of plastic there to melt and catch the knurled top. But we're going to heat it up, and then we're going to set this into the hole. Okay? So we do this. My favorite part, the dangerous part. Here we go. So heat this up. Now, you want to heat it nice and hot, but you don't want to overheat it to the point where it just becomes a melty mess when you go to insert it. It can be too hot. But in order to melt this, it's called PETG material, has to be about 500 degrees. Turn the torch off. Now, as it cools, I make sure that it's straight from all angles. I make sure it's straight. I just keep tweaking it as it cools. It's getting harder and harder. It's getting more and more solid as it cools, making sure it's straight. Keep turning it. Make sure it's straight. Then when it's good and straight and it's not moving on its own, when you let it go, now what you do is go ahead and thread it down. Thread it down. Screw that down all the way. Just like that, until you see it kind of poking out the other side. Now, take off that little booger on the end of the threads. Little booger, just peel that off. Right? Now, unscrew it, and you're good. You're golden, pony boy. There you go. Unscrew that. Would you look at that? Beautiful brass insert. Good forever. And what we're going to do is the exact same thing on the other side. Just like that, but on the other side. So, take another one of these brass inserts. Make sure the smooth edge is facing the end, the end of the screw. So the smooth side of the insert goes into the hole. The knurled side is the one that winds up gripping the plastic at the entrance to the hole. So, got that like that. This one now, smooth side towards the end is going to go bloop, right in there after we heat it up. Okay. Whoop, I fill this up. These run out very quickly, these butane torches run out almost. I have to fill it almost after every single operation. Okay. Heat this up. I would say, if I had to estimate, I'd say it's about 10 seconds on the flame. Twisting the whole time to make sure it's heated all the way around. And you're placing the knurled insert right in the kernel of the flame, right in the pointy part of the flame. Good, good. Smoky, smoky. Get that started. And turn the torch off. And just keep adjusting. Keep adjusting as you go. Make sure it's straight. Ooh, I overheated that a little bit. It's a little too melty. It's very wobbly. I have to support it. Okay, no big deal. If I know that, it's okay. But if you're not ready for it, that sudden liquidification, I don't know what you call that when it turns into liquefying of the plastic can be kind of disconcerting. It's like, what am I doing? It's running away with me, but it's okay. Just go slow. Try not to overheat. There we go. Now it's standing on its own, so I can very gently screw this. Now it's still wobbly. I could turn it or twist it or make it malformed if I wanted to at this point still. It's still soft. Screw that all the way until you see it come out the other side. Like that. And then just take the booger off. Pick the booger. Go ahead. Pick the booger. It's okay. I'm letting you do that. Dad says it's okay. There you go. Pick that. Wow, that's a stubborn booger. Flick it. You got to flick it. There you go. And take it out. There you go. Now we have two beautiful brass inserts, but we still have two kind of ugly non-outfitted holes on the other side that we're going to outfit with some brass inserts. But you can see what I mean, where you really need to make sure there's not too much plastic there, because if I now go to insert another one in here and there's too much plastic, it's going to bundle up inside and contaminate the threads and everything else. So it's just enough plastic left over that it'll grip that hot, sticky brass knurled nut insert. Wow, that was a lot of words. So here we go. Let's put this on here. Now you may find, like I'm finding now, this is a little difficult to get it threaded because it's boogered up with the plastic, but usually you can just force it on there. It'll clean it up. There you go. Cleaned up. Now, just always, please, make sure it's flush with the end. That's really important, because if you melt that plastic and it boogers up those threads, you're going to have an awful time trying to get that to unscrew from the insert, all that extra plastic on it. So just like this, heat it up. Nice and hot, like that. Turn it off, and we're going to insert. Boop. And just make sure it's straight. There you go. Good. I blow on it just a little bit. Speed it along a little bit. Yep. Good. Thread it through. Now, I can't go all the way through because I have one going in the opposite direction on the other side. So I'm just going like a few turns more towards the middle. Then I'm going to unscrew it. I don't want to damage the other one. Whoop. Unscrew it. And then we're going to do the final nut insert again. Smooth side on the end of the screw, and the knurled side towards the towards the inside of the screw, towards the, I'm trying to find different ways of saying that. Yeah. Smooth side into the hole. Knurled side towards the surface. There we go. Keep that up. About 10 seconds, I'd say, is about right. Yeah, that does seem about right. Okay. All right, and into the hole. And make sure it's straight. Yeah, also, please do this in a ventilated area. I'm smelling this just a little bit. I do have ventilation down here, but it could be turned up a bit more. I am smelling a little bit of fumage going on here, and it's not ideal. So there we go. Nice. Now we have, all right, this is so cool. Check this out. Now, I'm dropping everything today. Good Lord. All right. So I'm just going to drill, well, let's see, maybe go a little bit smaller. I'm just going to drill out the holes on these retainer caps. No, that's probably the right. Yep, I'm going to go with that one. Retainer, no, that's too big. Sorry. Changed my mind. I want a slightly smaller drill bit for this particular hole. Yes, hold on. Yeah, probably like, that's probably a little bit better. Probably not big enough, actually, but that's okay. I don't know what happened to my normal bit that I use for that. I don't know, it's around here somewhere. Okay. Yeah, my feeling is that's going to be a tad too small. Yeah, it's a little tight. I think I can make it work, but, well, no. Drill it out a little more. Yeah, that should be it. So in this kit that I'm going to be offering, it'll include this piece with the knurled inserts already done. And it will include all, obviously, thumb screws. This is a complete part here. So you've got this piece here, the basket, the top to retain the basket retainer, we'll call it. And then you have the thumb screws to hold in the basket. Yeah, I'll steal this one. And then you have on the other side, once we drill the hole in the white bucket, we'll be able to insert this and then hold it in place with 2 more thumb screws. Because, you know, you can never have too many thumb screws. 2 more thumb screws. So what would happen is this would go into the hole, and then from the other side of the bucket, you would have 2 holes drilled, and the kit includes a template, by the way, for drilling. And then these 2 thumb screws simply hold the piece in place. And then when you want to change the basket, you just undo these 2. Hopefully that makes sense. So that is how you do these brass inserts, and they work really well. I mean, you can torque these a bit and really get that tight without fearing that you're going to strip out the threads, which is what would definitely happen if you just tried to thread the plastic itself without an insert. It would strip right out when you try to torque it. So this plastic is very good. It's very durable. It's called PETG, and it's used in the 3D printing world. Extremely durable, but it's a little bit soft, which means that it's not ideal for threaded things. But once you put one of these in there, whew, that's a great combination. So you've got the durability of the threaded insert and the flexibility and durability of this type of plastic. So the 2 together are really a really good combination. So there you go. That's how you make that. I'll switch the camera back here. And what we're going to do is I'm going to show you in another video. I'm going to show you this bucket. I bought this bucket just for the demonstration video, where we're going to take this and we're going to cut the hole out and drill the 2 holes for the thumb screws pop that in and make our bucket. And I'll show you that separate video. I didn't want to put too much information into this one. So I'm already over the edge, I think. Okay, so we have the controllers to do. And we have... let's get this out of the way. Get this over here. Okay, so we have a couple controllers. And one of them we've more or less finished in the last video. This one we're going to do some wiring. The controller, the second controller, yep. And what else are we doing? You know what else we can do? Maybe do some wiring on the pumps. I can show you that. And let's see, what else can we do? Well, we'll start with that. We'll see where it goes. So, is that volume? Yeah. Let's turn that down. Oop. All right. Okay. Let's go back to bird's eye view. Boop. All right. So again, we are, oh, soldering iron. Yeah, I guess that would be helpful, huh? I mean, I could try to melt the solder with my mind, but I don't know. It takes a long time. All right. Let's see. Let's get this here. That there. And I realize, of course, a lot of people, most people probably, are never going to be soldering or any of this kind of stuff in their indoor grow room activities. You know, it's kind of an unusual thing. I get that. That's not why I'm doing this. Along the way, as I'm constructing these and building things for aeroponics and hydroponics, I do all these weird things in order to build these, and that's why I just wanted to share it. But I realize most people aren't going to do this. But if you are interested in doing these sorts of things, this is how you perhaps could go about it. Okay, that's why I do it. So people ask me, how do you do that? Well, let me show you. That's why I do this. Okay. Okay. Staying hydrated. And we are going to, soldering iron gets up to temp pretty quickly. It's a Weller soldering iron. They're known for Weller soldering irons, by the way, these Dilios, these blue ones. You see them in the movies all the time. They're popular with people who work with electronics. They, Weller, that name, it's kind of interesting. He was a scientist, engineer rather, sorry, in Germany during World War II. And as it was, you know, a lot of people, excuse me, who were otherwise just professionals, you know, doctors and lawyers and scientists and teachers and everybody, you know, it was kind of one of these join us or else type deals. And so a lot of people wound up joining the Nazi party because they were strong-armed into it by Hitler. And then after the war was over, they're like, nope, we didn't really want anything to do with it. We were strong-armed, and he was one of them. This guy Weller, and he was a really good engineer, and he he was known for complaining about how long it took for the soldering iron to get hot. And so after the war, he moved to, from what I understand, moved to America, and he came out with the Weller soldering iron that we all use today pretty much. And it is now known for getting hot, or achieving welding temperature, soldering temperature rather, really, really quickly. So literally when I turn this on, it takes about maybe 30 seconds and I'm up to temperature, which is really fast. So thank you, Mr. Weller. I don't know what your first name was, but you make a really great soldering iron, and the world owes you a little debt of gratitude. Okay, let's get some wire. And if you remember from the first video, I used two different types of wire here in these controllers. We will be using this red solid stranded wire otherwise called bell wire, informally, colloquially known as bell wire. It's a solid core wire. Yeah, that was blurry and it's not stripped, so you can't really see anything. Let me do that again. All right. So we have, get the wire stripped off there, the insulation stripped off. So we have, I think it's easier if I stand. That, boop. And that now, that's a little better demonstration. This is bell wire, single core bell wire, solid copper. Kind of expensive because it is solid copper. You know, the price of copper has gone up a bit. But the reason this is used, the reason I use this in the controllers is because, and I mentioned this in the last video, these timers that are used in hydroponics, aeroponics, whatever, they have little terminals right here. And these little terminals are very difficult to work with when you want to put more than a single wire into one of them. So what you do instead is you put a single one of these solid pieces of wire in there, and then you can solder anything else you need to this wire. And then you're not, then you're not boogering up your screw connection or your board or anything like that. It's a neater, safer, more electrically solid way to attach your components to the timer, if that makes sense. Okay. So what we do, if you remember this from last time, is I'm going to take this out of the case temporarily because it's easier that way. I just want to pop that out real quick because I'm making a U-shaped, I call it the hockey stick. When I make hockey sticks, it's just a piece of wire that I'm then going to bend, grip it in the middle, like that, maybe like that, bend one side, bend the other side, and I have a kind of a U shape, like that, right? Now, I take, oops, I should have been a little tighter, hold on. Like that. Okay, yeah, that's better. Okay, like that. U shape, right? Now I grip it here. All right. So that the edge straight across like that. Like that. And then bend it up. Whoop, so that it looks like, take it out. Okay. Looks like that. So it's a U-shaped, let me just, it's kind of hard to show on camera. Okay. It's a U-shaped and then bent wire. Jeez, that's difficult to show. And what it's going to do is I'm going to take this and then I'm going to put this into here, into the two center connections, because that's where I need to bridge the electricity and carry the negative wire over to the relay. So I need to bridge it. It's called a jumper, this piece of wire. So that is going to go in here. I'm just going to loosen these up. They're pretty tight when you get these. You kind of got it. That's why I took it out of the case too, because you kind of have to hold it with one hand and unscrew it with the other. Pretty tight. Okay, and you need to loosen them more than you think. In order to get the wire in there, you'll loosen it and then you'll go to jam the wire in there and it won't go and you'll wonder why. And if you just loosen it a little bit more, it'll go. So now I'm going to take the wire, for the camera's sake, I'm going to do this with the pliers so that you can see what I'm doing. but I'm just going into the two center terminals here. See if I can do this on camera. Come on. Now, difficult on camera. Let's try this. Well, I may need to loosen a little bit more. Yeah, it's a little tight. Hold on. Loosen that up. Yeah, this gauge of wire, there we go, is perfect for this. But if it's not fitting, I know I just need to loosen it a little bit more. That's what I did. So now you can see we have that little jumper there, which is perfect. Now we have something that's not only a jumper, not only does it jump where we need it to jump, but now we have something we can solder additional components to without having to jam it into that tiny little hole, if that makes sense. So now I did notice that it's not sitting evenly. I'm going to take it out. I'm going to trim it a little bit. I like it to be neat. I like it to be perfect. So now you can see what I'm talking about. It's not perfectly even. So what I do is I just get my cutters wherever they may be. There they are. And I'm just going to trim evenly. Like that. That's it. And remember, always aim your trimmings away from your work so that you don't short anything out or otherwise damage your work. So grip this again and put this in here. Maybe, maybe not. There we go. Nice and easy. Nice and easy. There we go. Nice and straight. See that? Nice, very nice. All right, now tighten it up. And when I say tighten, now don't do your final tightening yet, but when you're all done and we're buttoning this up, you want to tighten this down, but good, because you don't want it coming loose once you're in the green room. Dark room, sorry. Green room. That's hilarious. I've worked in my life in both dark rooms and green rooms, and I often use one in place of the other when I'm speaking. Sorry about that. I worked in dark rooms with photography, and I worked in green rooms with hydroponics. Okay, there we go. That's in. There we go. Beautiful. Now the same exact thing we're going to do for the other two terminals, but it's not going to be a U-shaped piece because we don't need a jumper for the other two. We just need a straight piece of wire so that we can make better connections with our timer. Okay, so I will cut a single piece here. I'll strip this insulation off. Like so. And then I'm going to just cut off as much as I need, which I think is about an inch, about like that. That's in my world, that's about 2 to 3 centimeters. And then we will, yeah, that's already loose. Okay, we're going to insert that into timer. These timers, by the way, are available on our website or on AliExpress. You can buy them from wherever. If you get them from us, here's what I can tell you. They are waterproofed, not waterproof, made water resistant, I should say, to be accurate. You can kind of see that conformal coating, it's called. A conformal coating is applied to these timers to seal them from the outside world. And I should have brought a UV light. You can see it jumps out at you in UV. It's UV active. So you put a UV light on here, you can see where you've coated and where it still needs to be coated. So I coat these in conformal coating, and they're made water resistant. The timing cycle is set up, and the little pieces are inserted in here already when they're sent out. So you get all of that if you buy from us. And I do that because I know you're going to have to do that eventually anyway, and a lot of people don't have these tools. So I do this work ahead of time, and some people appreciate that. So I'm going to tighten this a little bit. Again, not the final tightening, just the initial tightening. So we can solder. There we go. Now I'm going to bend that up like so. Like that. And if you buy one from the website, it arrives like this. Okay, so that you can solder right onto it. Well, with one more on here as well, with all 4 terminals outfitted with copper wires. There you go. That. Like that. I get it started with the pliers so I don't put stress on the board. And then I finish it by hand. This here, the bend, I mean. Okay, like that. Bend that over. And bend this over again. Start it with the pliers. Whoops. And then bend it the rest of the way with your hand, like that. Then you have something that looks like that. Nice and neat. You can solder onto the top there, onto the loop, onto the top there. Nice big contact area. I'm also going to bend this little loop just a tad because I found that if it's not perfect, it tends to obstruct the back of the controller, the back panel that we put on when we're all done, put this on. And if this little piece is not bent down far enough, it tends to block the cover from going on flat. So I bend it ahead of time, no big deal. Like that. Like that. And I'm just going to tighten that a wee bit because it's a little bit loose. Also, it's a little bit in my way. I need to be able to access the screw terminals. I bent it, meaning I bent it a wee bit too far. There we go. There we go. And then we'll move on to the next one. Where the heck is it? Oh, it's already in the it's in the unit. Okay. Let's take this out. Like so. And again, that conformal coating is kind of shiny. You can see it in the light. There it is. That's conformal coating. All right. I'll give you a link to that too. That's it's good stuff to have. If you do any work with electronics, it's going to be around a green room or around a greenhouse. I keep saying that. A green room. No, that's the thing on TV you wait in before you go on air. The green room. There's the green room, the dark room, and the greenhouse. Wow. All right. And I'm familiar with all 3, but can't be in all 3 at one time. Okay. Let's put the up. What did I forget? I forgot to loosen these first. Yes. Oh, those are nice and loose already. Nice. I lucked out. Sometimes they are, and sometimes they're way tight. Very strange. Probably depends who was in charge of inspection at the factory. There we go. Boop, and boop. And whoops, that needs to go a little farther. There we go. Like that. Now this time I did one of the end pieces first, the straight pieces first. That. And then I'm going to tighten that. That. And do another one exactly the same way. And again, these timers are available from the website, and they're made water resistant and outfitted with these copper pieces ahead of time like we're doing now. So what you're seeing is the labor part that goes into the parts that I sell on the website for people who are into this like I am. You make your own stuff if you want to. All right, there we go. I'm going to do a U shape. Do a double hockey stick. There we go. Again, make our loop. I'm going to do a little tighter loop this time. So as you can imagine, the width between the legs is determined by how far up the pliers you place this. The higher up it goes, the wider the space between the legs when I bend them. Does that make sense? Really wide, narrow. Really wide, narrow. I want about here. About here. Okay. Then grip it really hard, right? And then just take your thumb, bend it. All right. You can switch hands if you want to. Take the other side, bend it. You got your, let's see, how do I show this? Now you have, I didn't do a very good job with that. It's not very even, but yeah, you have that. I should really redo that. That needs to be a bit more even. Yeah, you know, on camera. It's difficult on camera. Okay, there we go, like that. And then I'm going to rebend. Like that. It's a little better. It's not perfect, but it's definitely good enough. Okay. Yeah, almost. There we go. Like that. Okay, then I'm going to grip it and I'm going to bend up to create my two hockey sticks. Like that. Now I have the double hockey sticks as well as the loop because it is a jumper like that, right? And now that is going to go middle right here. And again, that is the, on these timers, you need to carry the electricity from your input, from your VCC, your voltage in, over to your relay, because that's what you're switching on and off with the timer. And you do that using the jumper. You carry the electricity over. And that single wire gets the job done. All right, tighten this a little bit here. Like that. Boom. Now you have all your good stuff poking out there. And I'm just going to trim this a little bit. Try to even those up just a tad. And yeah, it's not bad. I'll refine them a little more in the very end. But I can make sure these are straight. And then I'm going to create my single bend over. Like that. Like that. All right. Like that. And then we can solder onto all of that. And this one looks like it's okay as far as it's pretty even with the top of the case here. So I don't think I have to bend that at all. And that'll be just fine. Yeah, I try to do that every time. It doesn't always work, but sometimes you have to give it a tiny little bend to clear that top. Okay, there we go. Now we have two timers ready to go. They are ready to go where? They're ready to go into our 3D printed case. And again, I'm doing this kit for you guys. Well, what can I show you? Let me see if I can find an example. What it will be a flat piece of plastic, 3D printed plastic that, well, I don't really have, well, okay. Yeah. This is pretty close. Okay. A flat piece of plastic, like so, right? With the tabs on the top so that you can attach this with the thumb screws, and then it hangs on the bucket, right? And the only difference is this would have, if it was your kit, it would have the cutouts for the timers, right? So that when you're done, it looks a bit like this, but it doesn't have sides on it, and you know, it doesn't have a back and stuff like that. It would just be a flat piece of plastic with places to put the stuff, and then you just wire it up according to the wiring diagram when you get it. Super simple. Everything's pre-arranged for assembly, like I was saying, with the wires in it and so forth. And off you go. Then you can build your own system right at home, Aeroponics, and you can get started and play around with aeroponics or hydroponics. You could also use these timers to run hydroponic pumps. No problem. Yeah, do anything you want. It's very flexible. So This one is the holder that holds the nutrient spray pump and the nutrient return pump. I'll show you that later. But this is similar to what you'd be getting. I wish I had one here to show you, but yeah, later on I will. This here is our holder for the timers. So whoop, put that there, take your timer, and these have little tabs on them. And this space is made exactly the right size so that they sit there, and then what you do is you just pop them in like that. Very satisfying click. And take your second one, make sure they are right side up, and then click it in place. And Bob's your uncle, as they say, right? All right, there we go. I actually do have an uncle named Bob, so for me, that expression works out really well. Okay. 2 timers, you 2-timing dog. All right, we've got one with all the wiring complete, ready to go. We've got another with just a dangly wire coming in from the power supply. We've got some wiring to do here. So we need to make that one look like that one. Let's do this. Okay, get our junk out of the way, get our solder and our flux. Because you're not much good without your solder and your flux. Ain't it the truth? All right, so this soldering iron turns down automatically when you're not using it. See, it's on 360 right now. If I just hit that button, boop, starts to go up again. Mr. Weller, thank you again for such a fast heating soldering iron. Yep, look at that. Yeah, that's awesome. Yeah, okay. Back to it. All right. So for this part of the operation, we don't use bell wire. For this part, we use what is called stranded wire. This is 26 gauge AWG, American wire gauge. Let's say that again. When you are going to find wire on Amazon or Alibaba or wherever you go to buy your wire, if you buy wire, you buy wire according to the gauge. And it's measured here in America by AWG, which stands for American Wire Gauge. And this wire here, I should say, the lower the number, the thicker the wire. So 10 gauge wire is like monster cable you use on the battery of your car. Actually, that's more like 8 gauge, I think. 8 AWG, 8 or 10 AWG. This wire is 26 AWG, very, very, very small compared to that 10 gauge monster cable. But this is what we need for this. It's nice and flexible, and it's not overkill. It's a little bit overkill, maybe. It's still a little big for this, but better overkill than, better too big than too little with wire. In most cases. Okay, let's take that. Okay, now usually I show you this little trick where I run a single wire, I wrap it around the terminal, and then I run back with the same wire without having to cut anything. I can't do that today because these power inputs, these jacks, come pre-wired with a what's called a pigtail, which is just this length of wire already attached to it. So that piece of wire is not quite long enough for me to do my little trick. So I'm afraid I'm going to have to cut this. That's a shame, but that's okay. These are it's a brand new type of power output. I was hoping was going to work out a little better, but it's fine. It's more labor. No big deal. Okay, so I'm going to run it here. And now what I'm doing is I'm running my positive power lead over to the positive power input of the top timer, which is the top timer is the one that controls the spray cycle. So it would, for example, once every, let's say 15 minutes, it would turn on the sprayers for 10 or 15 seconds. which would feed your plant roots. And then the bottom timer would turn on maybe at the same time or maybe a minute or two later, and it would run for about 30 seconds, just to be sure, and it would return all of the nutrient solution back to the nutrient bucket. 2 pumps. That's what these timers run. Now, if you're not doing aeroponics, if you're doing hydroponics, the top one could run a submersible pump, for example, which could flood your PVC pipes, nutrient film technique, whatever technique you're using. Timers are the heart and soul of it because they run your nutrient cycles. All right, so we got the positive hooked up. Now I'm going to hook up the negative, which goes to the middle terminal. The negative is going to go to the middle one, that little U-shaped piece. That's where the negative is going to go. The positive just went to the left side terminal. Okay, and cut that, keep it neat. Twisty, twisty. Whoops, a little more than that. Boy, I've been under stripping wire lately. I don't know why. You need to strip more. All right, there we go. Put that in there. Feed that through. Whoop, that way. Feed this through. How do I show this? Feed that through the loop of that copper loop there. Bend it over. And then we're going to solder that. Okay. Oh, get a little flux. I'll put some on there. Whoop, yeah. Let me show you that. So I'm just taking a tiny bit of flux, this goopy stuff, looks like snot, and I'm just putting a little bit where I'm about to create the solder joint. Tiny amount. It's probably way more than I need because I can't see it, but tiny amount right there. Yeah, and that helps the solder to flow into the joint. And what it does is it prevents oxidation, which is what happens when the solder gets hot, meets the air, it oxidizes, which prevents it from making a good connection, or it can. And the flux, or rosin, as it's also known, the snot, it prevents oxidation temporarily while you're soldering, just long enough that you can create your good solder joint, and then you just rinse off the residue and go on with your day. Okay. Need a little snipper doodle. There we go, snipper doodle. Trimmy trim. Keep it nice and neat. Again, take your bits and pieces of junk, bits of wire and whatnot that you trim off. Make sure they don't land back in your electronics. Throw them away. Yep. And then keep everything nice and clean. Yep. All right. Now we've got our positive run to our top timer, our negative run to our top timer. The negative is being passed to the next terminal. And now we need to hook up our switch. And the switch right here and here is a manual override. It's a manual operator. So when you push and hold this, it's running the nutrient spray pump. When you push and hold this, it's running actively the nutrient return pump. Spray, return, spray, return. And these are useful when you're setting up the system and you're priming the lines, getting the water to go through the lines for the first time. You need to hold down this button and get it to feed. You'll hear, like, push it down, you'll hear as the pump is running, and then hold this one down, a little higher pitch, a little smaller pump, while that feeds the nutrient solution back to the bucket. That's what these are used for. Okay, so we have positive, negative. Now we're going to hook up the switch, and all the switch does, see that switch has those two terminals. We're going to hook one terminal to terminal 4 on the timer, and the other terminal of the switch to terminal 3 on the timer. And what the timer normally does is when the timer cycle runs out after, let's say, 15 minutes, it shorts out these two terminals for like 15 seconds or whatever you tell it to. And that shorting out is what's turning on the pump. This switch will also short out those two terminals if we hook them up. And that way you're manually overriding the timer's function and running the pump manually by shorting these two out with a switch. That's what we're about to do. One terminal will go to terminal 4. The other terminal will go to terminal 3. So before I do that, I'm going to do pre-tinning of the two terminals on the switch. That just means laying down a little blob of solder so that you've got something to land on when you go to create your solder joint. Got a nice soft, blobby tin/lead pool of molten goodness. All right. Okay, make myself laugh. Let's go with, yeah, a little strip of, whoop, blocking the camera. A little strip of black wire. Okay, so this is just, again, this is just a jumper. Technically, I suppose, well, technically, I guess it's not a jumper. It's just a short wire, but it's going to run from the switch to the timer. So it doesn't need to be long. It just needs to run that short little distance. So as soon as I strip the wire, if you've never done this before, just go ahead, hold the bare end, twist the body of the wire itself. That gives you a beautiful twisted end. Flip it around, hold the bare wire, twist the body, gives you a nice, and kind of pull as you do it. Gives you a beautiful, beautiful twisted end like that. Okay. Now, what I like to do if I'm soldering this onto something like this, something solid, is I like to pre-tin this. What do I mean? I mean, move your work, create a little melted pool in your flux. It melts with heat, so you stick it in there, create a pool, little melty pool. Now take your bare wire and dip it in that pool, just like that. Just get a little goop on there. Goop the other side while you're there, just like that. That's probably way too much, actually, but you get the idea. Goop it up, and then, now I'm doing this one-handed, so I have to cheat. I'm going to put the solder down here. Then just go ahead and solder the end. Now remember, you heat the part and you let the solder flow onto the part. Do not heat the solder, heat the part. Heat the part and then let the solder flow onto the part. So this is literally the solder in this case is, oh, and then trim everything up. Make sure it's nice. The solder is literally flowing into the, there we go. The solder is flowing into the braided wire through what's called capillary action. It's wicking action. So if you put a little flux on there and you get it nice and hot and you melt the solder and then you touch it, the liquid solder just goes right into the braided wire and through capillary action. And then you have a nice hardened solid tip that you can now join very easily to your switch or to anything else, whatever. And we're going to just join it to the switch. That, boop, that. And I'm going to strip the other side of that wire. Yeah. And twisty, twisty. Twisty, twisty. Like that. Just going to check something real quick. Just want to make sure we are still. Yeah, I guess we are. Okay. Yeah, we're good. Who knows? Maybe we are, maybe we aren't. I don't know. Yeah, cool. So with twisty. Then I'm going to create my little melty pool again. It seems to have hardened up a bit. There we go. Boop. Dip the wire in the melty pool. Flux. There we go. And the other side. Boop. Just like that. And then pre-tin the ends. Boop. Once you get going, this goes really fast. I'm significantly slower on camera than I would be working, normally or whatever. But that's actually good. It allows me to show you guys how this actually works. But working slower. Here we go. Attach to the other side of the switch. Boop. Give it a few seconds. There we go. And now we're simply going to join those two wires. You know what? Let me do this. Let me entertain you. Let's see. Where's my stand? Where's the stand? Oh, crikey. I don't know. I was going to get another camera on this so you see a little better, but I'll do that next episode. All right. Now I'm going to pre-tin the solid copper pieces that we installed earlier, or hockey sticks. Yeah. Here we go. Makes it easier to attach to them. Negative to negative, or negative to the third terminal, and then the other side of the negative switch to the fourth terminal. And I know I mentioned it in the last video. I'll mention it again. When you switch something on and off in electronics, you can typically choose to either switch the positive lead or you can switch the negative lead. If you switch the positive lead in a higher voltage application, it can cause arcing. Like when the switch closes, that sort of thing. And then over time, that arcing can cause like a buildup of soot, I guess is what it is, just burn marks on the surface of the contacts, and then the switch dies. But if you switch the negative, then you don't get that arcing. Is the problem, that arcing. And as long as you don't have the arcing, that switch should last much longer. So I always switch the negative wire instead of the positive wire. I've done that ever since I learned about it. And that's a number of years. So, I mean, if there's a better way to say it or different advice, please do leave it in the comments. But that is the latest from the world of electronics. Okay. It's been true a long time. I'm just passing it along. Two more wires here, negative, for the other switch. Or for the other timer, rather, sorry. And again, twisty. Twisting by the pool. And then flux. Ooh, it's starting to harden up again. Here we go. Still soft enough, though. And pre-tin. Sometimes actually there's enough solder left on the tip of the soldering iron. You don't even need to pick up any new solder. You just run it along the edge and it's done. Go, boop, done, and boop, done. Just like that. Oh yeah. Now, go down to the switch, pre-tin the switch. I almost forgot. So I'm going to put a little blob of flux on each of the terminals. Just a small amount. Doesn't have to be much. Very small amount. Very small amount. The more you leave, the messier it gets. So don't leave a lot there and you'll be fine. Okay. What am I looking for? Yeah. There we go. Solder. And that. And then we're going to tin a wire Zip. Zip. Oops, redo that one. Zip. Okay. And this is probably, yep, that was getting solid again. There we go. Melty, melty. There are actually, I've seen them on Alibaba. There are actually these little heated cups you can put your flux in. It'll melt the entire thing. And it's for, you know, for factories if you're doing a buttload of soldering every day and you're doing this type of soldering, then you need to have something like that ready to go, right? So that's how it's done. You get a little heater for your flux. The tool for everything. Okay. Boop. And second one already ready. Like so. There you go. Now trim this just a wee bit. Trim away from your work. Ooh, man, that one almost put a hole in the wall. That was like a bullet. All right, here we go. Yeah, oh, you know what? You really should, I'm setting a bad example. You really should be wearing some sort of eye protection when you're snipping these wire pieces. For real, I have been hit in the eye before. It is not fun. And what happens is you trim this, and then this little nub just goes bing. And if it flies and hits you in the eye, it sucks and it's going to ruin your day. And probably not your eye. You probably won't ruin your eye per se, but it'll hurt like hell and it'll do damage. And don't do it. Wear eye protection. Yeah. Don't be like me. No, honestly, I just switched over to contact lenses for the first time in my life and still getting used to them. But one of the disadvantages is that I don't automatically have glasses on all the time now. So I don't automatically have protection. I have to keep that in mind. I used to have glasses on quite a bit. That would protect me. Built-in memory is full. What are you talking about? Built-in memory is full. That's crazy. All right, whatever. I think my computer just told me that I was recording for too long, so it's cutting me off. I'll figure it out. Whatever. That's cool. There we go. Boop. Now we have our switches hooked up for both of the timers. And now what we're going to do is we're going to hook to the jack here, which is where your pumps hook in. So you've got your nutrient spray pump and your nutrient return pump hooking into here. And we need to hook those 4 leads. So the top 2 leads, there are 4. 1, 2, and then 2 on the bottom. The top 2 are going to go to the top timer. The bottom 2 leads here are going to go to this timer. That's our rule, I guess you could say. Okay, and I decided in the other video, let me show you this, that from this point forward, when I'm using these types of connectors, that negative was going to be on the right side, positive was going to be on the left side. So negative, positive. Then on the bottom, negative, positive. So it's very difficult to show that on camera. Maybe I can show that on camera. Hold on. Unplug it. Okay. Sort of. All right. So, the focus there. Okay. So, negative, positive, negative to the right, positive to the left, and then on the bottom part of the plug, got another 2 wires, negative on one side and positive on the other side. And then when you plug it in, you've got 4 ports there. 2 of them go to the nutrient spray pump, 2 of them go to the nutrient return pump. Hopefully that makes sense. And these are really nice connectors. These are actually made for aircraft, airplanes. And they're waterproof and they're high durability and all sorts of good stuff. So, oh, and also importantly, they can only be plugged together one way. They are polarized, which prevents problems. Cool. Let's hook this up. I'm going to cut a fresh piece of wire, and then I'm going to strip the end. And whoops, that did not strip. Let's go do that again. Whoops, still didn't strip. Very strange. Okay, here we go. Twisty, twisty. Cool. I'm actually twisting the body. It looks like I'm twisting the wire. I'm not. I'm actually holding the wire and twisting the body. But it looks a bit deceptive on camera. That melty pool. Reach in, and then we're going to go attach the positive to the positive on the first terminal, along with the power, just right next to it, right next to where the power comes into the timer. We hook the power that will lead to the pump. The positive's on all the time. The only thing we're switching is the negative. And the negative will go to the fourth hole, the fourth terminal, which is the negative out that is only turned on when the timer is active. So after, those 10 or 15 minutes, the timer activates and that turns on the current to the fourth terminal, which then goes to the pump. Hopefully that made sense. I've now found like 15 ways of saying the same thing. Okay, let's run this one down here, and then we'll cut just enough that we can neatly attach to the plug right here. Our 2 terminals, negative and positive. Again, negative is going to be towards the right and negative towards the left. I'm sorry, negative towards the right and black right, red left. In this case, but in other designs, it's swapped back the other way. It depends, Sometimes there's no need to wire it one way or the other, right or left or whatever. I just choose one, kind of depends. As long as it works in the end, that's all people care about. Okay. All right, here we go. Multi-pool and pre-tin. Then the wire that, get it on the soldering iron. See, at this point, there's enough on the soldering iron itself. I didn't even really need to pick up any more solder. I did, but I didn't need to. Send that around there. And then the black to the right. And by the right, what I mean is, as I'm looking at the jack with all the electronics staring me in the face, as I'm looking at the jack, the right to me is this side. The left is this side. As I'm looking at the electronics with the plug in front of me. That's just, it's a matter of perspective, right? But for this project, that's what it means. Okay. Now, yes, again, I'm going to pre-tin that connector, the pins on that connector. And it's a little finagly. It's pretty in there. Yeah. Now, in order to get the other 2 terminals, what I actually have to do is rotate this around. I have to loosen it. Rotate it around 180 degrees so that I can access those two terminals that are on the opposite side of this. Yeah. Turn it. Oh, it's not loose yet. Hold on. And a different pair of pliers. Where are my... There they are. Okay. See if I can grip. Whoop, wrong one. Wrong one. Okay, there we go. Loosen. There we go. Lefty loosey. Righty tighty, lefty loosey. Okay, now, yep, twist. And now I can access the other two terminals. That. And obviously, if you were to order a controller like this from us, all this is done. I mean, I couldn't possibly ask people to to build their own controller from, you know, a pile of parts. That's just silly. So these do come constructed, all built, ready to go. If for some reason somebody wants this in kit form, let me know. But yeah, I know. I can't imagine that would be a thing. Okay, like that. You know what? I'm going to leave it loose because I'm just going to have to tighten it again or loosen it again. I'm just going to leave that loose so I can rotate it. Okay, so the top, the way I know this is the top in this case is because the lid, this little waterproof lid, attaches at the top. So I know where the top is. If I rotate it, if I rotate this switch and loosen it more, then oh, jeez. Yeah, these are really good connectors. They do not come loose once you tighten them. Okay, so when I rotate this, the entire lid is rotating. That's why I know the top is where the lid attaches, right? Yeah. So now I'm revealing the bottom two terminals. Now I'm revealing the top two terminals, right? Bottom two, top two. All right, here we go. Now, I want the top two for my top timer. Again, with the black or negative wire to the right. And the positive terminal to the left. Left, to left, to left, right, left. I don't know, but I've been told building controllers never gets old. All right, let's hook up the positive. Boy, that is tight. Man, I gotta get in there. You gotta be like skinny fingers to get in here. I do have kind of skinny fingers. There we go. Yep. Now we rotate. And then same thing, other side, but now we need to solder onto the bottom timer a wire leading to this. It's gonna be a really short one. It's a very short run. So we just need, like, let's say, like that. Yeah, it's about right. Okay, strip the ends. That did not work. Ooh, I think these are getting dull. I have to get a new blade. Here we go. All right. There we go. Twisty, twisty. Twisting by the pool. Twisty, twisty. Ah, there we go. Yeah, it gets a little difficult to twist it when you've got two next to each other. There we go. And we have it. Okay, now we're going to pre-tin this as per usual. Make your pool. Dippy, dippy. Like so. Move your work. Get your solder. You know what? I don't even need to pick up any more. Just whoop, whoop, whoop. Oh, careful of the hands. Oh, meteor. Okay. That. Sometimes you get a little blob on there. Just run it along again. It'll clean it up. Whoop. All right. Now hook to the two terminals on. Yeah. Basically, the easy way that I'm remembering to do this is the positives are on the same line and the negatives are on the same line up and down, right? So positive up above, positive down below. As above, so below. Okay, let me turn this again. I think I had too much solder on there. Oh, I do. Let me show you this. Hold on. I got to show you this. All right. This is a common problem with these, and I'm not going to make the mistake, but I was about to. Let me show you this. Where is the? There we go. These connectors. I don't know if you can see this, but I actually put too much solder on the connector. And now I have to go back in and I'm going to have to desolder it so that there's not a short right there. I don't know if you can see that. It's all like right here. Let's see, right here. There's a big ball of solder that kind of joins together at least two of those terminals, maybe three. So I'm going to desolder it and resolder it, neater with less solder, if that makes sense. Okay. All right. Go in here. Twisting by the pool. Is that on? Who knows? All right. Yeah, probably. Okay, let's desolder that. Come on. There we go. Yep. Ah, what a mess that was. Yeah, I'm glad I caught that. That could have been pretty bad. All right, now I have to be careful here because now I've got a bunch of solder balls floating around everywhere because I didn't use my desoldering tool the way I should have. Now I've got a little bit of a mess. So I'm going to very carefully desolder, remelt, I should say, and remove some of the solder. Break loose any melted bits. And again, this is one of those times where it would be very, very easy to damage something in here with a blob of hot solder that just went flying hither and yon. So you do have to be relatively careful when you're doing any kind of repair that you don't make everything worse. Because that, that could happen. Let's see here. Let's get our negative on there first. Yep, good, nice and clean. Very minimal amount of solder. This one, positive, whoops, positive. Yep, good. And not good. Now I have the opposite problem. I may not have enough solder on there. Yeah, that's the problem. Okay. No biggie. I'm just going to take a tiny bit. And we're gonna transfer over. There we go. Nice. Oops. Did we do that? Boy, it is really detailed sometimes. Finicky. There we go. Finally, geez, that was fighting me. All right, there we go. Now let's make sure. Yep, black to the right. Looks good. That's the top. Good, good. Twist it around. And then hook up our itty bitty shorty dude here. Actually, I'm going to trim just a little bit off the ends of those wires. A little more than I need. Again, away from your work. Eh. Sorry about that. Oh. Yep. All right. So let's see here. Sorry about that camera angle there. I didn't realize that was not on. Got another blob here. You know what? I'm going to have to grab a desoldering tool. Yep. I've got another blob. Now what would happen? Oh, I hope I have something here. I do not. Okay, wait, there it is. So what would happen is you'd go to hook it up and you'd short out your power supply if these were bridged. It's a little suction device. What you do is you plunger. It's a plunger, spring activated. Push this in, and then the end there is a suction pump. When you hit this button, it sucks up the hot solder into the tube. It's made out of metal, so it's pretty useful for situations like this. You need to remove some solder. Wow, yeah, it's a big blob. Holy cow. So heat it up. Like that. And it's good because it gets it out of your way so it can't short out something else, which is kind of the point. Now let's clean that up. Wow, this is really over soldered. My bad. Caused myself some problems here. Okay. Let's try that again. All right, heat it up. One more time. There we go. Yep. Think that worked. We'll find out. Think that worked. Did that work? Actually, I'm going to take this whole thing out and make sure it's clean because I don't think it is. Nope. Boy, I really overblobbed that. That was not well done. There we go. Cheese. Cheese Louise eating cheese. Look at that. Ah, okay, that's better. Jeez. Holy guacamole. That was something. That was a big blob. That was a mean blob. Okay, here we go. Put this back in here. Top to the top. Screw that on. Now, see, I do have to assemble this. I have to put this back in the case first before I solder it, because obviously the wires are attached at that point. So it has to be in the case first. Hopefully that made sense. So it would be nice if you could take all the components out of the case to solder them, but you can't. You got to solder them in place. That's the bottom line for most of them anyway. Okay. There we go. I did it again. I made it tight when I should have just left it loose. All right. There we go. How many times have I said that today? All right. Let's solder that again. I'm going to make sure that these are nice and clean. Am I blocking the camera? I don't know. Make sure these are nice and clean. Trim off a little bit off the end. Like so, and then negative to the right. Yep, perfecto. Ah, almost perfecto. Now it's perfecto. Good. And positive. Good. And spin her around. There we go. Again, positive to positive, negative to negative. So, or positive above positive, negative above negative, which means that, like, let's show you like this. Okay. So what that means is if we have, yeah, where are we? Right here. Positive on your left and negative on your right. Same thing down below. Positive and then positive below, negative above, negative below. Visually, the reason I do that is visually, it's easier to see what's going on your plug if you keep all the positives in line and all the negatives in line, since they're an even number of both. It's just easier for me to remember it that way. You can do it however you want. It doesn't matter, actually. As long as you get the electricity where it needs to go when it needs to get there, who cares? But for constructing a lot of these, I have to have systems so that I can have some consistency and, you know, the ability to repair and, yeah, all sorts of reasons why you create consistent patterns when you're building these things. But you don't have to. You do whatever you want. Ooh, having trouble seeing. Yeah, I should probably get one of those magnifier glass things for this work on video. It's very hard to see. Nope, under soldered now. Okay. And the way I know that is, now you have to be a little careful because once you start dealing with, yep, got to redo that. Once you start dealing with braided wire, what can happen is it can become see if I can get that. It can become unbraided, and then it can short out on you with the wire next to it. I don't know if that's showing up on camera, but it's messy. It's messy. That's the problem. And what I'm going to do is just snip the end off there and restrip it, retin it, resolder it. No biggie. Good. Yeah, like that. And then retin, or yeah, Get the melty pool. That. Hold on to that. And then we will see if that worked. Yes, perfect. Beautiful. And beautiful. Beautiful. Yep, good. You're golden, pony boy. There we go. Positive, positive, negative, negative. We've got to spin this back around like so. Yep. And we've got to attach these two wires. We've got one positive on the left side. Also have to still run a power supply to this one. Show you what I mean. When I originally ran the wire from the power outlet to the top timer, I never ran, I don't think I did. I did not. I never ran a continuing positive wire down to the bottom timer. So I need to power the bottom timer still. Yeah, there's that. Okay. That. That. Cool. 10. And solder. Trim. And run the wire around. Actually, I'm going to run it this way. Trim. Strip. Twist. Solder. Tin. Solder. Solder. And trim. Away from the work. Oh, shot me in the arm again. There we go. Trim that. Other side. I'm trimming the other side of that. Boom. And that, once I get this last wire soldered, negative, yep, that goes to the fourth terminal. That is our final connection. There we go. Okay, now theoretically, both of these timers ought to turn on when I plug it in. I'm going to double check all my wiring real quickly before I do that. Positive, running to positive. Positive, then running back to positive of the other timer. Good. Negative from the power running to center terminal of top timer. Correct. Center terminal of bottom timer. Wait. Negative. Oh, yeah, right there. Negative running there. Ah, nope. I never did run a negative power supply to the bottom timer. Interesting. I don't remember forgetting that. Okay. Let's just cut a negative. That's why we check it. Okay, let's run a negative wire here. Wow, that's a weird oversight. Okay. It's all right. We got it. We caught it. Okay. Strip. Okay. Twist. Twist. Now this again, this is the negative supply to the bottom timer. So this will be providing power to the timer itself, which will then, through that little U-shaped wire, pass on that negative power to the timer. Okay, so we're gonna you know what? Shoot and holler. That should have been longer. I need to run it all the way to the top timer. My bad. I need a much longer wire than that. I'm running from the top timer to the bottom timer, a single wire to connect the power, to jumper the power, but I cut one too small to reach from the top to the bottom timer, so I need to cut a new piece. My bad. Just a dumb on-camera error. Okay, let's see. I need that over here. About like that. Yep. That should do it. Like that. Twist. Twist. And 10. Whoops. That came untwisted. There we go. Good. Now we're going to run power negative power to negative power lead to the bottom timer. So like so. Good. Beautiful. Okay. Trim, trim, trim. Oh, got shot again. Trim. Remember, kids, eye protection. Here we go. Now that should be good to go. Now we are, I believe, ready for a test. Let me just double check here. Negative, 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 running back down to bottom timer. Negative on top timer, running the switch, switch, running back to negative. Good. And negative running to the bottom switch, connected to third and fourth terminals, correct. Negative running to, yep. Negative running to the switch, to the outlet, to the jack, positive, yes, good. And good, yep, should be good. Now, let's take a 12-volt power supply, and we will test it. All right, everybody. Cross your fingers. Ready? And nope. What's going on? Nope. Not working. What happened? Positive. Negative. Might it turned on? Is this a good one? Yeah, it's a good one. Huh. Yeah. Negative. Yep. Good. Good. Yep. Should be good. Yep. Negative. Power right there. Yep. Bring it back. Yep. Good. And Y. Huh. That's kind of odd. Looks good. Yep. Is that really positive? Should be. These are new jacks. Maybe they're reversed. Let me see here. Probably should have tested that first. Anytime you have a new part, it's a good idea to test it because manufacturers sometimes do make mistakes. Oh, it is reversed. Holy cow. That's weird. All right, you want to hear something weird? That's insane. Everywhere else in the world, red is positive, black is negative, but on this switch or this outlet that I just got, They're reversed. They reversed it. That is bizarro. Okay, all right. Well, it's not a big deal. I can just swap it, but it's it's not making me happy because, you know, color coding is done for a reason. Red is supposed to be positive. Black is not always negative, but red is supposed to be positive. Okay. Especially on a power outlet. Hello. So strange. It's all right. I'm just going to flop it. And I'm going to have to not order those outlets again. That's a shame. Okay. Flop these two. Just going to double check, make sure. I don't think that will damage the timers. I believe these have a built-in reverse polarity protection. I'm not 100% sure, but it should be okay. We'll find out. Wow, that is weird. This black and red are swapped. It's so strange. Okay. It's positive. Yep, sure enough. The negative is the center terminal. Weird. All right. That's the other thing that's weird. Center terminal of these, the center, let me put the cap on this one so we don't get confused. The center terminal of the power outlet is generally the positive, generally, not always, but generally. And the outer casing is typically the negative. It's reversed on these. I don't know why. So the negative and the positive on this pigtail I was telling you about, they're swapped. The black is the center terminal and the red is the outer casing. So weird. All right. Never seen that before, literally. Never. So strange. Okay. Well, hopefully it didn't damage the timer. We'll find out. If it did, I'm going to be sad, but I have a lot more timers. So it won't be that sad. Put flux on there. Yep. Sometimes you can tell you just need a little flux because it's not flowing correctly. All right, we've got positive. That's weird. That's weird. It feels wrong doing it this way. So strange. All right, that's fine. Positive is the negative, or red is the negative, and black is the positive. All right, if you say so. So strange. Now, if it did not damage the timers, we should be okay, and it should now turn on. Yes. What do you know? Beautiful. Look at that. Beautiful. Okay, so that's good to know. There is rather polarity protection on these timers, because if there was not, chances are these would have been damaged, but they were not damaged. So today is a good day. 2 thumbs up, 2 thumbs up, 2 thumbs to the side. All right. Let's see here. What else can I show you guys for today? That was pretty much what I had on the table. So now we have 2. Yep, 2 running timers there and there. And now I just need to set these so that they do the correct thing. And that is through here, set it so that, first of all, it's in seconds, not minutes. And then I'll set the top one for about 10 seconds so that it turns on the sprayer for 10 seconds. I'll turn the bottom one on for like 30 seconds, like every 10 minutes. That'll return all the nutrients. And there you go. So the next thing we're going to do is going to be, well, I'm going to switch the cameras back, first of all. And then the next thing we're going to do is we're going to build a grow bucket. But that's going to be what the heck is going on here? That's going to be a different episode. Oh, what's going on here? program. Yeah, is that right? Yeah, I don't know. Anyway, so geez, is this I hope this is actually shot. I just can't get a grip on these cameras here. I've got two different things showing up here. Hopefully you guys can see. I don't know if you can see me or not. It doesn't really matter, I guess. Anyway, thank you for joining me. Do remember to, there we go. There we go. Do remember to like and subscribe to the channel and hit that notification bell so you are notified when other cool videos come up. We're going to be covering, of course, the building of the grow bucket, and also I'm going to be doing some nutrient mixing, some nutrients both for vegetables and then different ones for cannabis. They're very different. Your nutrients for cannabis and your nutrients for vegetables should be very different. You're doing very different things, and we're going to cover that. And for now, I just want to say thank you. Enjoy the rest of your day and check us out again and like the channel. Thanks for tuning in.